Dear students, welcome back to Discrete Mathematical Structure. Myself, Professor Subramanya Bhagavat, your computer science coordinator. Today, I am going to explain you about quantifiers. What is quantifier? How do you define a quantifier? If you take any proposition, there are some words. Some words tells you about quantity, and no doubt that's a quantifier. Example, if you observe this, okay, wait. If you observe this, all squares are rectangle. Please carefully observe the word says all. All says about quantity, everyone, everything. Means this word all says about quantity. For every integer, second proposition C, for every integer x square is non-negative integer. For every, this is a says about quantity. So no doubt this is a quantifier. Same with third proposition if you observe, some determinants are equal to 0. Some, not all, some. This says about quantity. So in fourth one, if you observe, there exists a real number whose square is equal to itself or some number. This says about quantity. The words, what the words like all, for every, some, there exist. These are all the words says about quantity. No doubt, I call it as quantifiers. Here, the words all, every, some, there exist are associated with an idea of quantity. Such words are there. We call it as quantifiers. Okay, there are two main important quantifiers. First one, okay, is universal quantifier. Second one is existential quantifier. What is universal quantifier? If any word, I told you about some words like it says about for everyone or something like some words says about okay few. Okay, so there's a difference is there. Like if a proposition contains the words like for all or for, okay, this called as universal quantifiers. Symbol, this symbol can be used for that. Where if you observe that, okay, some word says about quantity like there exists an x or some or few, okay, that time this is called as existential quantifiers denoted by this symbol. Remember this. With the example through, I will explain you. So that concept will be very clear to you. First, observe this proposition. Proposition 1, I call it as proposition 1. All squares are rectangles. All squares are rectangles. So, squares, I take it as S. S is nothing but all square, not all, squares. Okay. And X, I take it as rectangle. So, I write the word, okay. I rewrite the word as, okay, for all X belongs to S. That is nothing but, okay, X belongs to set of S. X is elements of S. Symbolically, I'll write this statement as, don't get confused. I told you this, all squares, all should be, okay, right like this, okay. Next, squares, I have told you that this is S, squares is nothing but S, rectangle is nothing but X. So, I write this statement, proposition, right, all squares, okay, belong to, yeah, all squares. So I should write like this. Okay, wait. So this proposition can be easily written all this word. All x belongs to S, where P of x, where this denotes all. Okay, this quantifier says all for all, and Px is nothing but an open statement where x is a rectangle. Where x is a rectangle. So we have understood. Okay, all squares are rectangles can be written like this, can be written like this. For all x belongs to S. Okay, where S is nothing but a squares, P of x is nothing but, okay, x is an element of set S. Now, we have understood for all what is the, you should write this syntax. Okay. Next one, proposition 2, for every integer, same, for every integer, the same thing. This quantifier, this symbol should be used. Okay. He says, okay, for every integer x square is a non-negative integer. Okay. For every can be represented by this symbol, and integer, okay, integer I call it as a z, okay, I taking as integer as a z, and non-negative this non-negative integer as q. So I can write this whole statement like for every integer x square is a non-negative integer. I can write like this very easily: for all x belongs to z, where q of x, where this interval says all, okay, for every z is nothing but a integers, and qx is nothing but x square is non-negative integer, okay. So we understood that things, okay, don't get confused. For every, for every word is you should write this one, okay. This very easily can be written, okay, for every x belongs to z and q of x, where z is nothing but set of integers, qx is nothing but a open statement, x square is non-negative integers. Next one, carefully observe the preposition 3. Preposition 3, some determinants are equal to 0. Please carefully observe, not like previous examples. Previous examples he has used the word for all quantifiers, for all, for every, but he has here used some. That time, okay, these things used, okay, this symbol is used. So some determinants, okay, determinants D I am taking 0 equal to 0. Their statement I say take it as x, okay. But some determinants what he has taken as like this: for some x is belongs to D, then x is equal to 0, okay. Now how can I write in symbolic way? Some, how to write, you know that this is the way. Some of for some x belongs to D, where D is nothing but, okay, determinants, and x is nothing but equal to 0. X is nothing but open statement, s is equal to 0. Now next proposition, proposition 4, last proposition example, what he says: there exists a real number whose square is equal to itself. So I can write real number as r, okay, whose square is equal to itself. That open statement is q, okay, or q of x I take it as. So proposition I write there exists, word he has used there exist, means he should not use this not for all, because there exists word he has to use. So for the same thing like this symbol there exist belongs to r q of x, where this symbol says about there exists, and r, okay, r nothing but denotes the real numbers, and q of x stands for the these things whose square is equal to 0, whose square is equal to 0. So we have understood about the quantifiers, all, every, some, there exists, okay. You have to write this symbolical way. All and every is the, you write this, wait, please carefully observe this, okay, carefully observe this, okay. For all is the, okay, wait, for all is the, you have to write this, for all is the, okay, all, every, or everything, everyone, for n. But where some and there is the, you have to write this, that is the main difference, okay, this symbol, okay. Now I will solve okay, some questions, some problems, so that concept will be, am I right, very easy to better. Yeah, wait for 2 minutes. Some problems I'll take it, so that you understand the concepts very easy. I am taking like p of x, okay, I am taking p of x, wait, yeah, I'm taking like p of x is one sentence, x is greater than 0, and q of x, okay, q of x is nothing but I'm taking as, okay, x is even, x is even, x is even, that's the given statements I am taking, okay. Then, okay, I have to write these things like at least one integer is even, at least, okay, I should write this syntax, at least this qx, okay, so that qx is even. better I will give some examples, okay, some assignments, so concept will be very clear to you. Better, okay, I'll give some, yeah, some points so that concept will be easily understood. Okay, wait. Now the main thing is clear to you. One thing is very clear to you. That is universal quantifiers and existential quantifiers. Am I correct? Now, yeah. Next class I'll solve some more problems. So concept will be very clear to you.